rational functions. So rational functions, something like this. So how would you find the limits of these functions? Let's take one example. So limit x tends to 1, x minus 1, 2 minus x by x square minus 1. Okay. So now what happens? Again, x first step, always substitute the value and see what is it coming out. X tends to 1, this becomes 0, denominator above also it becomes 0, 0 by 0, indeterminate form. Try to simplify and get some terms, factors cancelled out at both numerator and denominator. So x minus 1 root 2 minus x, this becomes x minus 1 into x plus 1. Okay, these two gets cancelled. And why gets cancelled? Because x never tends to 1, means never becomes equal to 1, it just tends to 1. So x tends to 1, so this is now 2 minus 1, so 1 by 2. So this is the value. So what we did, so 0 by 0 indeterminate form it was getting, so we then just cancelled out some terms, because of which numerator and denominator was becoming 0. Okay, let's try something else. Next thing is limit 1 by 1 minus x minus 3 by 1 minus x whole cube. 1 minus x cube, x tends to 1. Again, so first step, try out the values. X tends to 1, this becomes 1 by 0 minus 3 by 1 minus 0. So in determinate form it is 1 by 0 minus 3 by 0, so not correct. So we should, what should we do now? Try to simplify this whole expression. Okay, so this is now 1 by 1 minus x minus 3 by 1 minus x, 1 plus x square. Okay, that is what it will be. Okay, so let it have a little bit clean. So now what will happen is this is equal to 1 minus x, 1 plus x square. So this becomes 1 plus x square and minus 3. Is that correct? Minus 3. So this is equal to x square plus x minus 2 by 1 minus x, 1 plus x square. So this is x minus 1 x plus 2 by x minus 1 1 plus x square. Okay, so now x minus 1, as x tends to 1 but never is equal to 1, we can cancel these terms out. So the value now it is, so limit x tends to 1 minus of x plus 2 by 1 plus x square. So this becomes 1 plus 2, which is minus 3 by 3, which is minus 1. Okay, so this is the value we get. So this is again of the form you have to simplify. First you substitute the value, you get indeterminate form. So then you simplify the expression, again cancel out some terms from numerator and denominator and get the limit. Okay, so let's see a few more examples. So one such example I could see is limit root 1 plus x minus 1 by x square, x tends to 0. Okay, again whenever trying out, Substitute the value first. 1 plus 0, 1 minus 1 is 0 by 0. Again, this is indeterminate form. So what we do is limit x tends to 0, root 1 plus x minus 1, root 1 plus x plus 1. So we rationalize it now. X square 1 plus x plus 1. Okay. So now what happens? This is limit x tends to 0, 1 plus x a minus b into a plus b is a square minus b square. So 1 gets cancelled. Here x square root 1 plus x plus 1. So this x and this gets cancelled out. Okay. Then what happens? So now also x tends to 0, so we are not getting very good form. So it is again 1 is there above, 1 by 0 form, 1 by 0, which is not very good. Okay. So again, but we can rationalize x tends to 0, root 1 plus x minus 1, and here we have x 1 plus x plus 1, 1 plus x minus 1. So what will it become now? So then also we see that here, if you see, so this will remain infinity. Okay, so this limit will be infinity. Here if you will try like this, you will again get the same expression. So this will be infinity. Okay. So our last question, and good interesting one. Okay, so that is limit x plus 1 to the power of 10, x plus 2 to the power of 10, x plus 3 to the power of 10 till x plus 100 to the power of 10 by x to the power of 10 plus 10 to the power of 10. X tends to infinity. So in these kind of problems, what you can do is, we see that x to the power of 10 is the highest power. Just try to, so again infinity by infinity, this is infinity by infinity, so indeterminate form. So we take out x here, so 1 plus 1 by x to the power of 10, x to the power of 10 plus x to the power of 10, 1 plus 2 by 10, 2 by x to the power of 10 plus x to the power of 10, 1 plus 3 by x to the power of 10, so on till x to the power of 10, 1 plus 100 by x to the power of 10. Okay, and here in the denominator also x to the power of 10, 1 plus 10 to the power of 10 by x to the power of 10. Now we can cancel this x to the power of 10 on both numerator and denominator, isn't it? So these x to the power of 10 terms gets cancelled. Limit x tends to 0, infinity, so 1 by x tends to 0, so 1 to the power of 10 everywhere it is. These term 2 by x, 3 by x, 100 by x, they all becomes 0, and hence 1 to the power of 10 everywhere it is 1 to the power of 10, and this gets summed up to 100 times. So 100 into 1 to the power of 10 by this term also vanishes, so 1. So this answer is 100. So this was about finding limits of some summations and then finding the limits of some rational functions. So I hope you understand these. and this video helps, I hope. So if you like this video, please subscribe to my YouTube channel. Thanks a lot.